We're going to start a brand new unit, and this is really an algebra unit. So if anybody was sort of like, oh, I wish I was in algebra, you're going to feel like you're in algebra right now. Today we're going to do solving two-step equations. Now I have to be honest, you have done two-step equations. This is a review. But the most important thing is not the answer, it is the process steps of how you got there. So you might come up with the right answer, but did you show the steps and did you do a good check? Did you check your answer? You can literally do all of these equations and know whether you got 100 or not. So again, today we're going to solve two-step equations, and our essential question for this unit has changed. We're talking about what is equivalence. So we're talking about something being equal to something. So in your book on page 110, and oh, by the way, we're back in volume 1, just to remind you, there is kind of just a quick one-step equation review. And some of these just seem downright silly. Like you look at that and you're like, I can figure out the answer and I understand that. But in a second, I'll explain why we need to show the steps. So this is called a one-step equation. So equivalence means equal. So on one side of the equation, we have 44. And on the other side, we have a variable minus 7. So we want to know what number, when you take away 7, do you get 44? And you say, oh, I can do that in my head. And I know you can. Just hold that thought. So what we do is we look at our variable. We ask ourselves, what's being done to the variable? And do you see we're subtracting 7? So in order to solve this equation and get the variable by itself isolated, this minus 7 has to take a hike. And we have it go to the opposite side of the equation by doing opposite operations. So you'll notice right here, here is the problem. And notice I'm adding 7 because that's the opposite of subtracting 7. But whatever I do to the right of the equation, I must do to the left. It's like a seesaw, like a teeter-totter that's in balance. And if I add 7 on the right, now it's out of balance. So I have to add 7 to both sides. 44 plus 7, and yes, you may use your calculator, but you should be able to do that, is 51. And on this side, I'm left with the k because this minus 7 plus 7 form what is called a zero pair. And k plus 0 is k. So they zero each other out. And so now the number that when I subtract 7 gives me 44 is the number 51. Now here's a second example where this time there's no operation like adding in or subtracting in between. Remember, it's the invisible dot for multiplication. So let me just stick in a dot right there so you know that that is multiplication. So the opposite of multiplying this time would be dividing. So I get my eye on the unknown. 18 times what number gives me negative 360? So to figure that out, I do the opposite of multiplying, which is to divide. And we showed dividing not with the little line and the dots, but as I've said several times this year, we show it by the line underneath. So we're going to divide both sides by that number in front, which is called the coefficient. And I'll show you that word in a second. So 18 divided by 18 is 1m, and negative 360 divided by 18 is negative 20. So if I was to take my calculator and take 18 times negative 20, sure enough, it equals negative 360. So the only number that can take the place of m is negative 20. Now down below, there's all of these problems, but I'm not going to step through all of them. I'm just going to take an addition one here, and I'm just going to take a look at this weird one down here for you. And then we got to move back up to the two-step equations is where we should be. So the first thing I look at in this one-step equation, and what I mean by one step is there's one number with the variable that needs to move to the other side. So the opposite of adding 8 would be to do what? Subtract 8. And I'm going to subtract 8 from the left-hand side of the equation. So I'm going to draw kind of a line here. Do you see it? So on the left-hand side, I'm going to take away 8. And on the right-hand side, I'm going to take away 8. This is going to leave an n, and here's my zero pair. So I have just n over here. And over here, negative 9 minus 8. Think it in your head check it in the calculator. What is that? Now, you might have been heading towards like -1, but hopefully you checked it in the calculator. Now, let me just talk about checking this. This answer should be the only number that when you take n out of this equation and you put in the -17, it better work. And that's how you can check. Like if you had accidentally put -1 in here and checked it, it wouldn't work. I'll show you how to show that check formally. So we're going to take this original equation and the n is going to leave, and the number that I think replaces it is going to take its spot. Now I check this by, does -17 plus 8 equal -9? You know, you can check that in the calculator to make sure that that's right. If you had put a -1 in there, -1 plus 8 would be 7, and that doesn't equal -9. And that would tell you, wait a minute, I've made a mistake. I'm actually going to jump down here just to look at the number 6. So we've got the variable w being divided by 4. What is the opposite of dividing by 4? Did you think multiplying by 4? That's what we're going to do to both sides. And when you multiply by 4, 4 divided by 4 will give you 1. So you're left with a coefficient, a number in front of 1, 1w. That's what you wanted. And over here, what's -8 times 4? A bad thing happening to a good person is a bad thing. And I think the only number that w can be is -32. So I'm going to check it. I'm going to go back in that original equation. Does -32 divided by 4 equal -8? And the answer is yes. Okay, so let's step it up, guys. Let's get to our two-step equation. So remember, I told you I'd show you this word. The number in front of the variable, in this case a 3, is called the coefficient. So you're going to hear me talk about that number. Now, a two-step equation now has two numbers. So not just the adding 3, but the multiplying by 2 as well. There are two steps that we have to do to get these numbers away from the x so we know what number, when you multiply it by 2 and add 3, equals 7. And I know right now you're saying, I can figure that out. Now I'm going to show you a picture of this. We'll do the steps, and then we'll take it up a notch with some negatives. So if you want to see a picture of what we're doing, here are the two x's, and here are the 1, 2, 3. So 2x's plus 3. And do you see the 7 over here? 1, 2, 3, 4, 5, 6, 7. And my goal is to get 1x over here. So this has to leave and these have to leave. We're going to start with the number and we're going to get rid of those 3. But if I take them off here, I have to take them off over there. So this is just a pictorial representation. It's called algebra tiles. So I'm going to take those off, and when I do, I'm going to be left with 2 x's, and then there's a 4 over here. Now that I have this equation, I need only 1x. So in order to kind of get rid of that, I've got to cut these in half. I've got to divide by 2. And when I divide by 2, I would have 1x over here. And when I divide by 2, my answer would be 2 on the other side. Now, if I go back up and I take 2 times 2, that would be 4. Add 3. Sure enough, it's 7. So in your book on page 122, here is that very problem done out using symbols, using algebra. And one of the things I talk about is called the Woodruff bubble. So I start by, I put a circle around the variable and the number that's attached to it by either multiplying or dividing. And I call that the no-fly zone. So you're not going to try to do anything with the 2. You're always going to undo what's outside first. So the opposite of adding would be to subtract 3. And I'm going to do it from the left, and I'm going to do it from the right. We like to do it horizontally, so down, vertically, down. So now the 2x didn't have anything changed, so it drops down. Here's your 0 pair, and 7 minus 3 is 4. You need to show these steps. Opposite of multiplying, divide both sides by 2, and there's the same answer we got a second ago. To check it, I'm going to go back into this original. There it is, and the x leaves and the 2 goes back in. And I use my order of operations. I'm going to multiply before I add. And when this works, when I get the same number on both sides and I did good math, then I have the right answer, which is 2. Now, I know some of you are saying right now, do I really have to show these steps? And here's my reaction. It's a big face slap. Why do I have to write down these steps? I can do it in my head. Okay, I'm going to show you a problem we're going to do in the future. It's on page 159, and it looks like this. Now, this one, I don't think you can see what P is in your head. So just trust me, believe it or not, we're going to get to this, just not yet. All right, so let's go back to our 2 steps. You're going to see me putting some Woodruff bubbles in here. So I want you to show me the first step to get rid of the adding 2, then do the math. I want you to show me the second step on both sides to get rid of the multiplying by 3. Then you should have your answer, and you're going to take your answer and check it back in the original. Can you stop and do the steps for this one, please? Let's see how you did. Did you start by subtracting 2 on both sides? When you did that, the 3x is still there, the 0 pair goes away, and 20 minus 2 is 18. The opposite of multiplying 3 is dividing by 3. 3 over 3 is just 1. I'm going to write that as the invisible 1. I'm just going to put x. And 18 divided by 3 is 6. So is 6 the only number that can replace x? Let's check. 3 times 6 plus 2, does that equal 20? Do your order of operations. You multiply before you add. And 18 plus 2, sure enough, is 20. Okay, this one at least has a negative in it. See if you can do this one. First step, the opposite of adding 5 is to subtract 5. The second step would be to divide by 2. Showing it on both sides, your answer should be -3. Is that the right answer? We're going to go back in our original. The n leaves, and the -3 is going to take its spot. 5 plus 2 times -3, does it equal -1? Careful, careful, careful. Order of operations, don't add. You got to multiply first, jump over the adding. 2 times -3 would give you 5 plus -6. And sure enough, 5 plus -6 is -1. And that shows a good check, so the answer is -3. So now we're going to do a tougher one. Now this one, the variable is hiding behind the minus. And people often make a mistake here. So what I would like you to do when you see that happen is we are going to do a same, change, change. We're going to change that minus to adding a negative. These are the same equations. We kept the 6 the same. We changed the minus to plus, and that positive 3x became a -3x. Now I want you to Woodruff bubble the -3x and don't touch this. This is the no-fly zone. Look outside. The opposite of adding 6 would be to subtract 6. If people don't make this change, they often put add 6 here, but subtraction does not go right to left. This 6 is positive. So to move it, you need to subtract. 6 minus 6 gives you the 0 pair. Now the second mistake is to cut that negative off. I call that cutting the arm off the number. Don't leave his arm hanging up there, people. He's -3x. And 21 minus 6 is 15. Now, the opposite of multiplying is to divide. But again, don't divide by 3. That's a -3. Negative divided by a negative is the positive, so that's a +1. And a positive divided by a negative, a good thing happening to a bad person would be a bad thing. X is -5. I'm going to put it back in the original. See right there. 6 minus 3 times -5 would be -15. And if we same, change this, 6 plus 15 is 21. And the answer, sure enough, is -5. So a common error, I just told you a second ago, and this one would be to divide by 3 rather than -3. And this is just a Woodruffism. If that number in front of the variable is a negative, I say don't cut the arm off the number. You'll leave it bleeding, people, bleeding, I tell you. Okay, your turn. So in this one, let's solve both of these. And over here, guys, if you want to know, the opposite of dividing What would that be? Let's start with F, though. Try this one. You should have started by subtracting 2. So you want to kind of Woodruff bubble here. Don't touch the -3 yet. There's your 0 pair, and -19 minus 2 is -21. And if you're getting those wrong, please check yourself in the calculator. Okay, here's where you got to be careful. You're going to divide. The opposite of multiplying by -3 is to divide by -3, not 3. Don't cut the arm off the number. And a negative divided by a negative, a bad thing happening to a bad person would be a good thing. And remember, you can check in your calculator. I think the only number that's going to work in that original equation is a 7. Let's check it. I'm going to rewrite this equation, take out the x, and put in the 7. And I'm questioning right now whether it works. Multiply first, add second, and because that comes out to the same number, 7 is the only number that we can replace x with. Okay, try this one, please. All right, first of all, don't touch the n in the -3. You're going to start by adding 2. When you add 2 on this side, you should see -16. Now, the opposite of dividing by -3 is multiplying by -3. That is the one step you can write on the same line. These are going to cancel, leaving one n, and over here, a negative times a negative is a positive, and it will be 48. Let's check it. So the question is, 48 divided by -3, take away 2, is that -18? So I'm going to rewrite that. I'm going to pick up my calculator. I'm going to divide before I subtract. And when I divide 48 by -3, I get -16. And -16 minus 2 is -18. And I am a happy girl. So just to show you a two-step real-world equation here, just so you can see where do we use this stuff. Here's an example. So Chicago's lowest recorded temperature in degrees Fahrenheit was -27 degrees. Wow. And they want you to solve the equation -27 equals 1.8 C plus 32. And when you do this equation, your answer will be the degrees Celsius that -27 degrees is. So I'm going to take that equation, and I'm not going to touch the 1.8 C. I'm going to undo adding 32. I'm going to subtract 32 from both sides. -27 minus 32 is -59, and this makes a 0 pair. Now to undo multiplying by 1.8, I'm going to divide by 1.8, and you may absolutely use your calculator. -59 divided by 1.8 will be -32.8. So Chicago's lowest recorded temperature in Celsius is -32.8 degrees Celsius. And that's just an example of where we use a two-step equation in the real world. So today we're talking about solving two-step equations. And you just have to show your steps. Because to be honest, I don't think up here you were going to guess what C was. So in order to solve for it, we first don't touch the coefficient. We don't touch the number that's attached to the C, either by multiplication or division. We start by undoing the adding or the subtracting, and you do the opposite operation to get it to go to the opposite side. So you're not going to add 27. That would bring him closer to the variable. You need to lose both the 32 and the 1.8. Don't bring this guy over, right? So we're going to subtract 32. And then once you have a one-step equation, you're going to touch that coefficient by doing the opposite operation. It is mandatory that you show your steps. They not only are important to get the right answer, they count for steps. So if you wrote -32 on both sides, you get a point. If you divided both sides by 1.8, you'd get a point. If you got the right answer, you get a point. And then again, let's just talk about when you do a good check, that would be a point. So there are 4 points here. 1, 2, right answer 3, and a good check 4. It's your turn now to practice when I see you next. I hope you all have a